to millimeters. What do we have to do to get from meters to millimeters? We need to times by 100 and times by 10, which is, in essence is timesing by 1,000, not 2. Someone just say 2? Hope not. Okay, times 1,000, which means moving the decimal place how many places? 1, 2, 3 places to the right. 1, 2, 3. What's our answer? 3, 1, 0, 0. All good? All right. Alex, what do I do next for 0.89 millimeters centimeters?
Well, you have to divide. No, you do divide by 10.
So we're going from millimeters to centimeters.
Yes.
So we are going to divide by 10,
Yes.
which Callum means what?
0.089.
0.089 centimeters. So we just move the decimal place one place to the left. You can add those zeros in as we go. Kilometers to centimeters. What do we have to do? Say it a bit louder. We're going to times by 1,000 and then times by 100, which is the same as saying times by how many zeros? 5 zeros. I don't mind if you can't read what 100,000 is the number, okay? Which means we're moving the decimal place how many places? 5 times to the right? To the right. Okay, so 1, 2, 3, 4, 5. How many zeros are going to be added onto that 2? 4. 4. Not 5. So be aware, it's not adding zeros to your answer, it's moving the decimal place. 20,000 centimeters. Everyone okay with that? All right. So I think you guys are fine with perimeter in terms of knowing how to be able to actually just find distances on, squares, rectangles, things like that. You can now use, Erin, Pythagoras to find the hypotenuse if you had a triangle. But there's one shape we do need to know a formula for perimeter. What do you think it might be of those shapes I called out before? There's a particular formula for a particular shape. Circles, okay? So we are just going to look at circumference, which is the perimeter of a circle, okay? Perimeter and perimeter of sectors, because these are probably the hardest bit of perimeter, really. All right, so circumference shouldn't be too hard. If you have a circle, what are some of the things we need to know? So what's this line here if I have a circle? Radius, so we're going to say R is the radius. What's the outside of the circle called? C is the circumference. Okay, we'll just write C because we've already written up there. Okay, and what is as long as it goes right through the middle, D equals the diameter. Okay, so what is the formula? And everyone gets it wrong because they mix it up with area. What is the formula for circumference of a circle? 2 pi r, okay? So C equals 2 pi r. How else could we write 2 lots of r? No. 2 lots of r equals diameter. 2 lots of half of the diameter equals the diameter. So, or circumference equals pi times diameter. Could use either one because they mean the same thing. Everyone okay with that? Everyone know where the pi button is on their calculator, all of those things. All right, so quick example and then we're moving on. If I have this, I'm trying to find the circumference. I can either write circumference equals 2 times pi times 3, which is the radius, or I could write C equals 6 times pi, or pi times 6. They both mean the same thing. because 2 times 3 is 6. And we get our answer, which someone's going to put in their calculator kindly. Thank you, Ruby. Eight, 849, did you say? So 85. Anything with circumference is in centimetres, not centimetres squared, etc. Okay? So it's just centimetres. Length is always centimetres, metres, kilometres as its measurement. Okay, so the next thing we need to be able to do, though, is look at a sector or a quadrant or a semicircle. Okay, so we need to know those words. So let's start with a semicircle. Or, yeah, so semicircle, what do you reckon that is? Half a circle, yeah? It has to go through that midpoint, half a circle. What does a quadrant look like? It's a quarter, okay? What quadrant? What would, not a quadrangle, quadrant. What would a quadrant, what angle would a quadrant have in the middle of it? 90 degrees, so you're going to have a right angle in there. Sector. Good, okay, so just 2, and notice, because I've just put them in, there'll be dashes there, so that there's always like this, what measurements are they going to be where the dashes are? Not the diameter, they're going to be the same, and they're going to be the radius. So they all have 2 lots of the radius, and then a sector is just any sort of measurement. So I'll just put like a theta sign in there. So any, so a sector could be that, or it could be that. Okay, so it's any sort of measurement as we go. However, we can use the same formula whether we're using a sector, a quadrant, or a semicircle, as long as we know what the degrees are in each one. So a semicircle, what are the degrees here? What's the angle? 180. If you know that, you're all good. The right angle is how many degrees? 90. And then the others, it depends on what angle you get. So how do you think we find the perimeter? Notice it's not the circumference, because the circumference is a whole circle. It's the perimeter of this shape. So the perimeter of a sector, or any of these, we're just going to call them all sector, can be found how? Good. Okay, so for each of them, notice we've got 2 radii there, okay? Radius, another radius, yeah? So if we look at the perimeter equals 2 lots of r, that gives us the yellow bit. 1 radius, another radius. 1 radius, another radius. 1 radius, another radius. Okay, so we've got 2 lots of r. What do we still need to be able to find the rest of the perimeter of this shape? The circle part, okay? So we need to be able to find this part, or this part, and this part, okay, for each shape. So to do that, we have to add on a proportion of the circle. And the proportion is what degrees it is. So I'm just going to do a theta sign for whatever angle we're looking at. We'll do an example later. Theta over. Now, how many degrees are there in a whole circle? 360. So we divide whatever angle we have by 360. And then we have to times that. So that's the proportion of the circumference we're finding. What circumference should we use? We're going to use 2 pi r. Why do you reckon we're going to use 2 pi r rather than pi times diameter? Hun? Yeah, because you're already using the radius, so you may as well just keep using the radius for the whole thing. Just be careful with this if you have like a shape like this, and then it's also got like a square on the bottom. You're not going to have to add the 2 radii there, because it's going to be the outside of the shape. So just be careful of composite shapes with these things, because this formula works for if it's just a sector. because you've got the radius, and that little part of that shape. So, was there a question? All right, so that bit finds us the blue part. Does that make sense to everybody? Yellow, blue, yeah? All right, so let's do an example. E.g., find the perimeter of this shape. That is a degree sign. It doesn't say 200, it says 20 degrees. What do I do? 2 times 12 plus 20 over 360 times 2 times pi times 12. And we get our answer. Everyone okay with that? All right. Someone will find me an answer later on. Okay, your homework for the weekend is exercise 8A. Now, it says you need to find the perimeter and the area. You don't need to find the area, just the perimeter of questions 1 to 8. Some are a bit challenging. Some are a bit easy. So just the perimeter, you don't need to find the area. Any questions? All right, you've got 5 minutes, you can get started. Yes.